చేయొచ్చా మాట్లాడచ్చు. Good afternoon to all the participants. Just we will wait for another 5 minutes for the expert to join, and also other participants also will join.
Good afternoon, sir. Good afternoon, Dr. Srinivasrao.
Dr. Dhandapani ji.
Yes, sir. Good afternoon, sir. Good afternoon.
Sir, good afternoon, sir. Good afternoon, sir. How are you,
Good
sir?
afternoon to all the esteemed faculty members of the State Agriculture Universities and ICAR research institutes and other institutes, and also my beloved PG and PhD students of various disciplines all over the country belonging to SAUs and also ICAR institutes. Today is the fourth day of the 5-day national workshop conducted virtually on advanced research methodologies in agriculture extension, that is organized by the Department of Agriculture Extension Education, Agriculture College Bapatla. Today's topic is on confirmatory factor analysis, that is to be delivered by Dr. A. Dhandapani, Principal Scientist of Statistics working in National Academy of Agriculture Research Management, Hyderabad. Just I want to say a few words about him. Dr. A. Dhandapani started his career way back in the year 96 in the Institute of National Center for Integrated Pest Management and continued there for over 12 years. Later, he joined National Academy of Agriculture Research Management in the year 2009 as Principal Scientist, Statistics and Computer Applications at NAARM. And he is working, is very much involved in developing ICT solution for pest surveillance and integrated pest management. And also his areas of interest include statistical analysis for experimental data and sample surveys, ICT solutions for agriculture, software development for statistical designs and analysis. And also he is very much involved in developing the policy papers related to agriculture on ICTs and also statistical designs, and is closely working with NAARM for the last 12 years or 13 years, and he is now dealing with the topic given to him on confirmatory factor analysis, which is an important tool. It can be used by all the faculty members for their research programs. With this brief introduction, I now request Dr. A. Dhandapani to go with the presentation. Thank you very much, sir.
Thank you, sir. Thank you very much, Dowsat. Let me thank you for giving me this opportunity. And without wasting much time, let me straight away share my screen. Okay, sir, can you enable the
Enable. Is doing it, sir.
Yeah, sure.
It is enabled, sir.
Yeah. So good afternoon, all of you. And today's topic, confirmatory factor analysis, or what is commonly abbreviated as CFA, is one of the multivariate data analysis technique. And this, like any other multivariate technique, if you want to learn the theory about it, it will be highly complex. But if you want to apply it, you need to do several things. But actual analysis will be, the way you do will be very, very 1 or 2 steps only, you will get all the answers. But before you go for the analysis and after you get the results, you need to do a lot of work. This is true for example, cluster analysis or factor analysis or several multivariate techniques. So in this lecture, I'm not going into the theoretical aspect or what is confirmatory analysis, how the coefficients or loadings are going to be estimated. All these things, I'm not going to deal with it. So what I'm going to do is that I will introduce you briefly what do you mean by factor analysis. And there are 2 types of factor analysis are there, and what are those, and when you will use which one. And then I will move on to confirmatory factor analysis with a small example, and then try to tell you that what needs to be done before you go for confirmatory factor analysis and why we do that. And then what are the stages in confirmatory factor analysis? And then finally, I will try to show you one simple example in R. You can use many of, and what are the software tools are available, that also I will tell. So the confirmatory factor analysis, in general, what do you mean by factor analysis is that when you want to analyze interdependency of variables, interdependency, if you have only one variable, you are going to have its mean and variance. So there is not much, nothing is there to do, nothing more to look into. But once you have more than one variable, say, let us say 2 variables are there. Now you have mean of these 2 variables, fine. If you want to compare them, you can compare them with any test of significance, fine. But when you talk about the variances, now the variances of these variance of one particular variable, part of that is coming within itself or that variable itself, and part of it comes from its relationship, a covariance or correlation with another variable. So that means when you have 2 variables, you have 2 variances and 1 covariances. Now, if you talk about multiple variables, say if I have 10 variables or 20 variables, then you are having that many variances and several covariances, all pairwise covariances or correlations you are going to get. Now the question comes is that how do we summarize these, or how do you analyze these multiple variables together? So for that purpose, factor analysis, what we try to do is, can we group the highly correlated variables together? And if possible, can we identify them? What do you mean, why these variables are coming together? And so for these 2 purposes, these groups, they are called factors or latents. So that is why these variables are called, this analysis is called factor analysis. And factor analysis also can be used for reduction of data. So where we use factor analysis in social sciences is, one is you can use it for scale development to identify whether the scale which you are doing is fine or not. This you can do. And the most another biggest use of factor analysis is you can also use, or you can develop or validate the relationship structures. So this is why we go for what is this factor analysis. Now, there are 2 types of factor analysis are there. One is called exploratory factor analysis. Another one is called confirmatory factor analysis. Now, when you talk about exploratory factor analysis, it is something like your exploratory design. When you talk about your research, you say that this is in social sciences, many times you will say, my research topic is exploratory in nature. In exploratory in nature means that you don't have I mean, you have not fixed your idea, or you are not, you have some little bit idea about what you are studying, but you have not completely made up your mind that what are your hypotheses, or how you are going to do that. In other words, you have collected some data, and then using the data, you are trying to see what kind of trend or what kind of things are being given by the data. So, which means that you have not assumed any prior, you have not assumed any prior in relationship, or you have not assumed any kind of relationship, or you have not even know how many factors are there in your data set. So this approach is called exploratory factor analysis. So exploratory factor analysis is a kind of first step in your scale development, because this gives you which variables or which items to be included in a particular scale if you are developing a new scale. So exploratory factor analysis will give you that much of information. But confirmatory factor analysis, on the other hand, you try to do when you have an established scale, or when you have having some kind of relationship. You are assuming that, okay, these are my dependent variables, these are my independent variables, and these variables are related in this way. So this is, once you have that kind of model, then confirmatory analysis, confirmatory factor analysis will be useful to test whether that kind of model which you have you have hypothesized, or you have thought about it, whether that kind of model will work, or or whether they are correct or not. How do you test it? We can test it with confirmative fact analysis. So this confirmative fact analysis is one broad technique called what is called as structural equation models. What we are going to do in confirmative fact analysis is that we are going to fit several relationships. The relationships may be something like a linear regression only, but if we are not going to fit these linear regressions or any kind of relationship one by one, but rather we are going to fit all of them together. So this CFA is part of what is called as structural equation models. Structural equation models are what is called, it is a broader term, and CFA is one part of SEM or structural equation models. There are several other structural equation model techniques are there. CFA is one. SEM itself, people call it just most of the time it will be for fitting kind of econometric relationships. So that is also SEM, that also part of SEM. Then there is something called partial least square path models. Even path analysis also is, they're all part of what is called a structural equation model. So we are going to talk only about confirmative fact analysis as CFA. So which means that we have some kind of hypothesized relationship, and we know how many factors are there, and we know how they are related. So let me quickly, let me ask you a question. That is, suppose I want to model the success of a cricket team in a T20 matches. See, now these kind of analysis, these kind of things, these kind of modeling is done in various fields, particularly if you talk about sports analytics. People try to understand, okay, because huge money is involved. So when huge money is involved, people try to understand, okay, how do I improve? How I can, because you can say that you can train people, you can do all these things, practice and so many things, but ultimately success is what matters for the team owners or the team management. So how do you do it? Now, I don't know, you just think about it, how do you model this? Now, these kind of questions are very common. I'm putting it in a very general way, but you can also think about, say, for example, if you are working for in business, people talk about, say, human, wherever the human beings are involved, like say human resources or HRD, they'll try to understand, okay, whether my employees are satisfied, or if I am going to intervene, or if I'm going to introduce some kind of, say, HR tools, maybe kind of reward system, or maybe a kind of some other, maybe several things. They try to intervene and then try to see that whether that intervention was successful or not. So all these things are you have to have some kind of model in your mind. Okay, this is what is going to be there. And if this model works, then if you are sure about this model, then you can think of how do you measure this model, or how do you fit this model. And then once you are able to fit this model, whether that model is good, and if the model is found to be good, then you can understand that the components of that model, then you can see that, okay, how do I improve these particular components, say particular variable, and whether that, and then how much success I am going to get. Now, I don't know, if you think about it, I don't know whether it may not be possible to interact. So I'll give you one very simple hypothetical model. I can think of the success of a cricket team may depend upon, say, its batting abilities and bowling efforts, or batting efforts and bowling efforts. See, I'm talking about the final results. I'm not talking about the existing strength of the team or all these things. It is only on final performance based on the performance we are trying to see. Now, these three are batting, bowling, or success. You all understand what you mean by batting or batting efforts or bowling efforts or success of a cricket team. But these are, how do you measure it? Now the question is, how do you measure it? Now, in this relationship, what it says is that batting efforts and bowling efforts determine success. So that is what this relationship gives you. The relationship gives you in this way. Now the question is, how do you measure? How do you measure? So similarly, when in many social sciences, you can develop this kind of hypothetical model, or already the models are available. Now all these hypothetical models shows only the relationship among the constructs or the factors and other things. So in this model, people will be calling it as constructs or factors, this batting, bowling, and success. They all will be called as factors or constructs. Now, once you have this kind of model, the next question comes is how do you estimate, or how do you measure it, and how do you do it? So this kind of conceptualizing the relationship using these constructs or factors, this is what you as a social science researchers, if you want to improve, or if you want to become successful, particularly the students, you need to look at these kind of relationship. You have to think about this. How do I construct these kind of relationships? So if you are able to do it, and then this particular techniques, confirmatory factor analysis, which I'm going to tell, will help you to test whether that kind of relationship, what our model you are taught about, you have derived at, whether it is valid or not. Now, these constructs or factors, usually people call it as latent. Latent means that the ideas which cannot be measured directly, but you understand what you mean by success. But how do you measure it? That cannot be measured directly. You need to use some other variables which implies success. Or when you say somebody is successful, how it is, in what way how it will be reflected, which kind of variables will reflect on these if someone is successful. So for example, if you talk about success of a cricket team, maybe you can think about, say, what is their win-loss ratio, or how many times they won, how many cups they won, or how many times they reached the final, and so many things you can think of, which essentially says that the team is successful, right? Now, this kind of hypothetical model, you can develop on your own, but many of the issues which involves human behavior, this area, the entire area of psychometrics, which is a branch of psychology, which deals with this kind of quantitative measurement of latent or psychological constructs. So it is not necessary that you need to derive your own. If you derive it, then that is well and good. That will add to the knowledge, existing knowledge. But also there are several well-known constructs or hypothetical models which are available, which can be used for a particular, because as a social sciences researcher, you may be looking at a particular aspect. So when you are looking at this particular aspect, most of the time that would have been studied elsewhere. So you can use a similar model and then try to see that whether that kind of model works in your situation or not. For example, let me quote, in all our training programs in our academy, we particularly related to young scientists, when they are coming, we try to assess their personality profiling. Personality profiling means whether there is a well-known models are there. So we try to assess their personality profiling and then try to tell them that this is your personality profile, where you are weak or where you are good, and what kind of things you need to do, something like that. So these kind of hypothetical models will be useful. So you can now, so that is what the initial thing which you need when you want to go for CFA. Now, the problem comes is that once you have set a model, the next question comes is that how do I validate this model? Because anyone can come up with a diagram and say that this is how these things are related. So nobody is going to agree for that unless and until you show some kind of validation. Now, it is also possible that maybe there is some kind of existing model is there, and you feel that is not sufficient to depict all kinds of relationship or whatever relationship you are seeing. Then you want to improve them, or you want to change them, or you want to add something more onto them. So now you have 2 or 3 competing models. Now, how do you take a decision that which model is good? Now, the third aspect is that, say, you have an established model is there, and that model, whether it works, because these models might have been developed for some other country or some other culture. Now, whether that kind of same model can work, because if it works, then your time will be saved, because it is already established. So if you are able to say that same kind of model works in our country also, or in your situation also, then it will save a lot of time and resources, and then we can fit that model and then try to take any decisions. So for all these 3 questions, you can have multiple ways. Like I was telling you, as if these all falls under structural equation models, you can all these things can be validated using any of the structural equation models. CFA, in fact, it provides you a very simple way to answer all these questions. So that is what we are trying to learn, or we are trying to understand from. Right. So in short, or to summarize whatever I told you, so when using CFA, you can test any kind of measurement theory in the sense that how do you measure a particular latent or a fact. So you can use it for testing this measurement theory. But as against this exploratory factor analysis, every factors or EFA factors are derived from statistical reserves. You have taken the data, you have applied some kind of statistical tool, and then from that tool you are extracting it. So it is more about the factors are given by a statistical results or fitting of a statistical model, and then you are coming up. But in CFA, you are knowing that these are the number of factors exist, and which variable is available or which variable is associated to which factor. All these things are known before the analysis. Whereas in exploratory factor analysis, we don't have any kind of idea how many factors are there, or which variable will be reflected, or which variable will be included in which factor. All these things we don't. After conducting EFA, we will come to know this. But in CFA, we need to know all these things. So in other words, before you go to CFA, your model should be complete. So let me stop for let me open it for some discussion. If you have any quick questions, I can anything which is not covered, whatever I told you, which anything is not clear, you can ask me. Then we can move ahead with how do you depict this model, or how these models are formed. So that is I will try to explain it. Any quick questions, anything?
The participants can ask any question, any clarification at this stage. Anyone? I think there are no questions.
Okay, no problem. Okay, now let me explain to you some of the symbols and some of the things which are usually used in these models, because you will come across several models in social sciences, and when some results are depicted, usually in the form of a diagram, which I showed you. So how these kind of visual diagrams are, what is this, what do you mean by this visual diagram? How you need to understand when you see a conceptual model, how do you understand that these are the models which are there. Now, this visual diagram in CFA, these are all also called as path diagrams. See, path diagrams depict the relationship between any specific measured variables and how they are and their associated constructs. So if you think that this particular variable is going to be related to a particular construct or a particular factor, then you draw a line. This shows that how they are related. Now, this variable or the relationship may be a direct relationship, maybe there, or it could be a multiple relationships may be there. And there are other things which are there in the sense that there will be some kind of a mediation effects and moderation effects, and that is some external factor are also affecting the relationship. So this is so many complicated models are there, but let me first give you very simple models, and then I will explain to you what kind of complex models one can define. So now it is not that you will draw yourself that this is how these parts are going to be there in your model. So this should be based upon sound principle. That means you understand that when you say that this particular variable is associated with this construct, you must have some sound idea or sound argument that yes, this variable is related to this particular construct, and that is why I'm showing it in my model. So the symbols usually, there are several symbols which are used. So typically anything you consider it as latent. That means they are not measured directly. That is the most important aspect. So they are not part of your data set. There is no variable associated with that, but you want to use it or you want to name them. So these are nothing but your construct or factors. So all latent concepts or factors or constructs will be depicted using a circles or ovals or ellipses in this path diagram. Anything which you are able to measure it, that is, you will in your data set, there will be a variable, that particular variable. When you collect your data, these variables will be there. So those variables, all those variables which are measured, they will be shown as rectangles. Then with respect to the relationship, if you see a double-headed curved arrows in any path diagram, that means it indicates the correlational or covariance relationship between whichever is connected. It could be variables also, or it could be factors also. So these are called correlational or covariance. This will be a double-headed curved arrows. A direct relationship, if you see a single-headed arrows, that means it is a relationship between construct and the associated measured variables. And there will be some terms called error variances or error terms. This will be shown either with the E1, E2, E3, or it may be just a number or a letters only, or even it could be in a small circle or an ellipse. So these are typically the kind of path relationship, a path diagram you will see. And let me put up the same one. Now, this is a simple path diagram. So what I am showing you is that batting, it is going to be measured by two variables. And bowling, I'm just showing it with two variables like x3, x4, and success, I'm going to have x5 and x6. Now, x1, x2, x3, x4, x5, x6, they can be measured. Say, for example, x5, I can take win-loss ratio, so of that particular team. X6 may be number of wins outside away wins, number of away wins, something like that. So this x5, x6, whatever you are writing it, x1, x2, or y1, y2, or whatever symbol you are going to use, these are considered to be the variables which can be measured, Now the direction shows that this batting is manifested in these variables. That means if your batting efforts increases or batting efforts, depending on the batting efforts, they are all reflected in this x1 and x2. X1 may be number of runs scored in a power play, or x2 may be something like the highest number of 50 scored, or number of persons scoring more than 30, or say run rate, whatever it is. So these could be those variables which reflect the batting efforts of the team. Same way, x3, x4 may be number of wickets taken, and so on, or economy rate, or strike rate, and so on. So all these variables which are measured and how they are related, that is what you are showing it in this. Now, with respect to this, I'm not writing it E3, E4, associated with all your measured variables, there will be something called error variances associated with this. Now, what do you mean by these error variances? Means that, see, something which is some of the whatever value you are seeing here in x1, part of it is coming because of this whatever construct we are talking about, right? And some of them are purely related to that variability is purely related to the particular variable. Or you can say that a E1 or E2, they reflect the inability of, or the variation which is not directly related to whatever construct you are having. So this E1, E2, and so on can be thought about it. So typically it will be called as error variances. So these error variances are expected to be low, because if this is more, that means this x1 variable is not, most of the variation is because of error, not because of the construct to which it is related. So that is why this error variances you can think in that term. So you may this is one. The second thing is that in this variable, I'm not showing any other. I mean, x1 is related only to one construct, or each variable is related to only one construct. It may be possible in some models that x1 may be related to more than one construct also, or more than one factor also. That is also possible. And again, there could be a relationship between the, say, for example, there could be a relationship between these also. It is not necessary that there will not be any relationship. There will be only relationship between one construct to another construct in that fashion, right? So it could be possible. It could be possible that you may have multiple paths also. So if I have something like this, that means success part of this, it goes into success, or there is one path from batting leads to success. Another one, batting, it is going in indirectly also, batting to bowling, and from bowling to success also. It may not be valid in this case, but you can find in this fashion. And also it is possible that there could be a relationship between these two error terms. That also may be there. So these are various complexities one can think of, or it may be necessary depending on the situations what you are having it. So all these things are, so whenever you see a path diagram, you should be in a position to understand that how this kind of what kind of relationship the particular model is depicting. So this is important. So once you understand this, then when you are trying to develop your own model, or when you are trying to validate this model, then you will be in a better position to understand, and then able to look at it whether this model is sufficient, or you want to change this model because you feel that it is insufficient to describe the phenomena which this model is supposed to do. So this kind of diagrams you can always see in many of these papers. So you get used to these kind of notations or this kind of depiction in your in this. So this kind of model is very much required before we go for confirmatory factor analysis. If you don't have this, or if you don't have any of this kind of diagram in your mind, or you have not developed it, then you cannot go into CFA. Just I have 6 variables I want to fit a confirmatory factor analysis. You cannot do it. So unless you have this, then only you can go for confirmatory factor analysis. Otherwise, you cannot go. Right now. So once you have this idea about your hypothetical model, so what are these are the 4 basic stages, or 4 stages. In each stage, you need to, if you see here, in these 4 stages, most of your work will involve in these first 3 stages. So much work you have to do, and then finally, when with the use of software, then what is going to happen is this 4th stage is you don't have to spend too much time in this 4th stage, which is what you actually require. That is, how do I assess the model validity? With the software, you can straight away look into the result, and then you can try and see your model is valid, or how good is your model, or if you want to compare the 2 models, all these things you can do it very easily. But the first 3 steps are going to be the really tough stages, because you need to take care of many things. And once you spend more time on this, and then once you go for the 4th stage, then you will be very easily you can complete your task. In fact, if you see the code for running this particular any example, you will hardly find that there are only 2 steps are there, or maximum 3 steps will be there. One, to define your model in the way that a diagram is there, you need to depict it. And then second is you need to fit, that will be the second step, and the third one will be your output. So that is how simple it is, and you will be looking at few statistics to understand how good is your fit. But this first stage, first and second and third stages are very important. So what is the first stage? In the first stage, you are defining all your individual constructs. That is, which factors to include, and how are you going to measure? So this in this stage, this is what you will be doing. Specify all the constructs that will comprise in your measurement model. It could be an existing scale or a construct. If you are going to use it, anything existing, then this step will be already completed, so there is no problem. But if you are going for a new scale, then you need to follow the usual scale development process. And then you come to, once you have completed your scale and you have identified that these are my constructs and these are the items in those constructs, all these things you have come. And then once you completed all these things, then you come to this CFA and define these constructs and their measurement model. So that will be the last step. In your scaling development, you will come, once you have everything is final, then if you want to validate it, you will come here and then you will try to validate it. So that is what you are going to do here. Now, the second one is, how are you going to measure it? So like I showed you that there are 3 circles I showed, and then I showed the relationship. So that is the relationship among the constructs. So we need to define this in the stage 2. In the first, you will be defining this relationship among the constructs. And the second thing is you will try to decide upon what are the associated measurement variables. I have not designed, or I have not decided on what kind of measurement I'm going to use it in that hypothetical example. But when you go for a CFA, you need to decide upon this. Okay, these are the measurement variables which I'm going to take it. And these measurement variables are going to be in my measurement model. Now, when you are going to introduce, or when you are going to use this kind of measurement model, then one feature which is always good to have, that is what is called as unidimensionality. Unidimensionality means that whatever measured variables you are having, that can be explained by only one underlying. Suppose I have a set of, say, x1 and x2, I was saying. So these x1 and x2, it can be explained only by batting. It should not be explained by some other, say, bowling or other things. So this unidimensionality is preferred. So in other words, each measured variable is related to only one constant. So this is an ideal situation. So x1 is associated with one factor, x2 is associated again with the same factor, x3 may be associated with some other factors. So this is an ideal situation. But sometimes I don't know whether if you have done or if you have learned about exploratory factor analysis. What happens in exploratory factor analysis is that when you see the factor solution, or when you see the variables, what is called as loadings, you will see that a same variable may be coming in more than one factor. It may have very high loadings. So high loadings means that that particular variable is important in that particular factor. So that kind of situation, that a single variable may be associated with more than one constant. So as far as the diagram is concerned, we can just draw an additional path. That's all. Right? There is nothing is there. So I will say that x1 is also related to success, or x1 is also related to bowling. So it is simple as far as the model is concerned. Depiction of model is concerned. But this is going to be a problem, because when you talk about this, what is called as these cross loadings, where high loadings of the same variable in more than one construct, then it becomes difficult to validate your model. Pure psychometric models, if you see, they say that each variable unidimensionality is preferred. If you don't have unidimensionality, there is something missing in your model development. So that is what they say. But many times these cross loadings will happen. So in that case, the only thing is that as far as the path diagram is concerned, we need to draw additional path only. That's all. So x1 may be related to say more than one factor. So that is possible. So that is possible. Some in structural equation model also, many econometric relationship, if you see that the same variable may be coming in more than one relationship. So that is possible. That is possible. Now, the second aspect in this, continuing in this, is that when in your model, there are two error, covariances are there, variance covariances are there. Now, there are two things which are there. One is called within construct error covariances, and another one is between construct error covariances. Within construct covariances means that that is nothing but the relationship between the error variances of same variables of same construct. Variables of same construct. Say, for example, in my example, if x1 and x2 are related, there is some kind of relationship between x1 and x2, then that is called, because x1 and x2 is associated with one factor, so then the relationship between x1 and x2 will be called as within construct error covariance. covariances, within construct error covariances. On the other hand, if there is a covariance between x1 and x3, x1 is related to one factor, x3 is related to another factor, x3 is related to another factor. In that case, this is called between construct error covariances. Now, again, as it is as simple in depicting this, I need to draw only a curved line to denote where if it is a within construct or between construct, you just have to draw the line, right? There is no issue. But all these things affect just a minute. Hello. Okay. But many times when you want a model, particularly when you are looking for a validity of a construct, this if you don't have unidimensionality, or if you don't have the between or within error variances, then it becomes easy, or you can prove that your construct is valid. So many times in most of these models, so what we try to do is we impose these constraints in the sense that all constructs are unidimensional. That means we assume, or we set this, that the cross loadings are constraints to be zero. We don't depict them in our relationship. So that means we are restricting ourselves that all constructs are unidimensional, no cross loadings are allowed. Then the second thing is, again, we also set that the covariances, no covariances is allowed neither between or nor within. So which means that we are all constraining them to be zero. So this is our assumption in our model. When we are not showing it, means that we are assuming that it is going to be zero. So this is a feature of the model, not the assumption of the statistical technique or a tool. So you assume that they are all zero, and that's why you are not showing it. So you have to be keep in mind that this is some kind of assumption which you are making it when you are going to fit this model. So this kind of model is called congeneric measurement model. Congeneric measurement model is preferred because if you can say that if your model is good, or if you are through CFA, you are able to show that this model is good, or the fit is good, then it proves your validity of your model. Otherwise, if congeneric measurement models are not there, or if you don't use it, then your construct validity will be difficult to prove. That is the idea, or that is the one why we need to go for congeneric measurement model. But otherwise, as far as the fitting is concerned, or otherwise the depiction in the diagram or estimation, it won't make any difficult. Only thing is that the number of parameters you are going to estimate will increase, so that will have an effect on your items as well as on the sample size. So these are the other things you have to take care. But otherwise, as far as the estimation procedure is concerned, it's not going to be a problem, as even if you don't have a congeneric measurement model. But for interpretation purpose, or if you want to prove that your construct is valid, then you may have to go for congeneric measurement model. Okay. Now, so I told you about, we are still in stage 2 only. So we are making some kind of assumption in our model. We have depicted our model. We have shown that these are the how these our constructs are related. And we have also made some kind of assumptions that every measured variable will be associated with one construct only, and there is no between or within error covariances. So that is something we made our assumptions, and then now there are few more things you need to keep in mind, or you have to ensure in stage 2 before you undertake this study. Still, we have not come to the stage that how are we going to collect the data and other things. So we are still talking about in stage 2, how are we going to proceed? How are you going to which items are going to be there per construct? So typically people, these are items are nothing but the variables. Earlier, I was using the term variables. These are nothing but items are the statements in your questionnaire or other things. In your scale, you may have some statements. So these statements only I'm calling it as items. Now, the next question and the next thing we need to decide about is about the items per construct. I'm not talking about which item to be included because that is going to depend upon your research problems. I'm looking at how many items should be there at least. So that is what I'm trying to see. I'm trying to answer that issue. So that issue I'm trying to tell you. If you include very few items, say only one, in some models you will find that, particularly sometimes for the dependent variables, you will find that there is only one item is there, because you feel that one single item will explain about everything about that particular dependent variable. So if you have very few items in confirmatory factor analysis, what happens is that your model may not be estimated. The model may not be estimated. So this is a problem. And if you have too many items, say you have included 10 or 20 or 30 items per construct. I'm talking about per construct. I'm not talking about total number of items in the entire model. How many variables are there? I'm not talking about it. For a particular construct or a particular factors, how many items are there? Now, if you have too many items, then what may happen is that, for example, the same example I will continue. I will go on adding in bowling, say, let us say how many catches are made, how many runouts are made, and so many variables, so many items I'm adding it in as a bowling effort. Now, if I'm go on adding these, it may be possible that the items which I'm adding, it may not be directly related to that particular one, or even if it is indirectly, it may be talking about, but I'm looking at some other subfactor. It may be something like a fielding efforts. So I'm not calling them as a fielding effort, but I'm trying to include it in the bowling itself. So these kind of subfactors are there, then it may be difficult for you to understand the model. So if you include too many, then again the cross loadings may come, because the same item may be related to more than one construct also, though that all these things will come. And the second one is if you have too many items, then to get a valid result, you may require more sample size. We'll come to the sample size in stage 3, how many samples you require. But this, if you have too many items, then you are going to have this. Now, for identification of your model, means that if you will be able to fit this model, you need minimum of 3 items per construct. Now, why this logic is required is why these three items per construct is required is that we try to measure what is called as degrees of freedom. Degrees of freedom in this year is how many total number of unique variance and covariance terms are there in your model, which you can estimate from your model. So that is that minus how many parameters are going to be estimated. Now, if you have p items in a particular construct, then say I was telling you that if I have two variables or two items, x1 and x2, so there will be two variances, variance of x1 and variance of x2, and then there is going to be a covariance of x1 and x2. So that means you can have three variance and covariance terms will be there if you have two measured items. So in general, if you have p measured items, then p into p plus 1 by 2. It is nothing but you visualize a correlation matrix between p variables. So what you have is the diagonal, right? P will be there, and the off diagonal or the upper portion of the matrix or a lower portion of the matrix. If you try to count, then it is going to be p into p plus 1 by 2. So now how many parameters have to be estimated? So that question can be answered by, first is, for each variable, you need to estimate its coefficient, how it is related to the construct, and what is the error variance. So that means for each measured variable, you will have to estimate two parameters, and then plus whatever paths are there between the construct. So that coefficients also you need to estimate it. So that means, for example, in my earlier example, there were three constructs were there: batting, bowling, and success. And each of these construct, we were having two items per construct, x1, x2, or x3, x4, x4, x5. So for each construct, if I see, there are three variance covariance terms are there, two variances and one variance covariance term. So three variance covariance terms are there for per constructs. So I have three constructs. So total number of in unique terms I can have is 9. So this is the maximum. This is the one which I can do. Now, if I look at the number of parameters, so there are for each variable, if you see, there are 4 are there. So for x1, the coefficient of x1 and variance of x1. So that is 2. I need to estimate. So like that, for each construct, there are 2 variables are there. So 4 parameters I need to estimate. And for 3 constructs, so 12 parameters are to be estimated. And then there are 2 paths are there from success. From batting to success or bowling to success. So that means there are 14 parameters you need to estimate, but you have total number of unique terms are 9. So your degrees of freedom, 9 minus 14 is going to be negative, which means that you cannot identify or you cannot estimate this model. So whenever the degrees of freedom is less than 0, then this model is called under-identified model. Under-identified. See, it all again, we are looking at, looking at only the constructs, number of items per constructs. If your degrees of freedom is equal to 0, then it is called just identified model. If it is greater than 0, then it is going to be over-identified. So if you have 3 items per construct, then what happens is that you can find that for a simple model, you can try and find out that your degrees of freedom will be exactly equal to 0. So on the other hand, if you have 4 or more items, then your degrees of freedom will be more than 0. So minimum you have to ensure, if you want to identify your model or you want to fit your model, you need to have minimum of 4 items per construct. But as I told you earlier, that if you go on increasing this number of items per construct, then you will end up with other issues also. So ideally speaking, 4 or 5 constructs are what is usually suggested, but you don't go for less than 3. If you go for less than 3, the model may not be identified. Now, the one more thing is that the overall model may be identified even if some part of the model may not be, it may not be possible. For some construct, you may have only one item only, but your overall, you may have additional degrees of freedom in some other construct, because in that construct, you have 6 items or something like that. the overall item overall model may still be estimated. Even for one construct, you have only one item. But when you talk about the fitting of the complete model may be still possible. But remember this requirement in that 4 items per construct will be required. This is again it is there in other structural equation models also, right? It is there in, even if you think about linear regression also, there also the number of parameters should be less than the total sample size, or whatever sample size you are having. Otherwise, you will not be able to do that. But R square, if your number of parameters is equivalent to exactly number of items, R square will become 1. So if I have 5 terms in my model and only with 5 observation, if I try to fit, my R square will be 1. So that is the problem. So this is this covers the stage 2. So in stage 2, you have to ensure your model, each construct is having at least 4 items. You have also identified that how these there is no cross loadings. If you want to make sure you want to validate your construct, then make sure that there is no all your constructs are unidimensional, and also there is no within or between covariances are depicted or available in your model. So this you are making sure that this is there. This completes your stage 2. In stage 2, then you have the complete model which are there, which you are able to keep it for steady. Now we'll come to the steady design, or the stage 3. So wherein you have to decide about various things, including sample size, including how you are going to execute this study. And I'm not going into this. How do you collect this? How do you word your questions? All these things I'm not going to talk about. So in general, in CFA, what kind of measurement variables, what kind of these items can be you can include in CFA? So typically you can have ordinal variables, say something like a 5-point Likert scale or 10-point scale, or even you can have a quantitative variable. But you cannot have a nominal variable. But other than that, you can have an ordinal variable or a quantitative variable. And again, for some construct, you may have an ordinal variable with the 5-point scale. In some other construct, your items may be a quantitative variables. In some other, it may be a 10-point scale or interval scale. So it does not, you don't have to bother about it. Even it need not be of same type. Even within construct also, it need not be of same type. So it is only this, it has to satisfy, it should be an ordinal variable or a quantitative variable. The third aspect is that for some technique, multivariate technique, it is always suggested that you go for normalization, particularly if you have a quantitative variable. For example, in cluster analysis, if you have a quantitative variable, it is the first step you need to do is you go for what is called as normalization or standardization. So normalization or standardization means usually what it means is that you subtract every value for a particular variable, you subtract each value from its mean and divide it by the standard deviation. So if you do this, what happens is that all your quantitative variables will have mean 0 and variance 1. So it ensures that all your quantitative variables becomes unitless. Otherwise, what happens is that if I have a quantitative variable which is in 4 digits, and there is another quantitative variable which is in 1 digit or 2 digit, the variances will be very high for large values, and for small values, the variances may be small. So that is why people go for this. But as far as the CFA is concerned, even if you have a quantitative variable, you don't have to go for normalization. But if you have items which are, say, what is called as negatively worded, or I mean, the statements are negative, some statements may be positive, some statement may be negative. So if you have that kind of items, then if you want, you can make them into the same form, because otherwise what will happen is that the signs will be, I mean, you may have some loadings may be positive, some may be negative. So if you may have the wordings in negative sense, but you can, before you go for CFA, you can change the scaling, you can reverse the scales, and so that it becomes in the same way, it becomes in the positive. So that all these things you have to do, but otherwise, typically CFA does not require any kind of normality, or all other things are not required. So you can do that. Now, in the study design also, you need to see what should be your minimum sample size. Now, the sample size again is a very, I mean, it's not an easy question to answer. So there are certain guidelines which are there. So these guidelines, typically, it will be in the form of respondents to variable, respondent to parameters to be estimated. So that some kind of, I mean, sample size recommendation will be in this form. For example, the book which I referred earlier here, if you, per parameter to be estimated, you must have 10 respondents, or sample size of 10 per parameter you have to take, 10 cases per parameter to be estimated. So this is one kind of, or they may say, sometimes people may say even 15 also, 15:1, 15:1. So this is one kind of guideline which is there. So the other one which is typically used is in terms of number of constructs you are having. And the second thing is, what is the, you want to ensure that the coefficients which you are getting are loadings which you are getting are higher. So if you are a 5 or fewer constructs, 5 or fewer constructs with more than 3 items per construct, this is also important. If you have like this, then about 100 is required. But if you have more constructs and you want to reduce this, the item communalities or the loadings of that particular items, then you need to increase this. For example, I think about 200, sample size of 200 for 8 or 7 or 8 constructs with the item communalities around almost same this. So in other words, so this is some kind of guidelines. It is not basically, it's not based upon any formula or anything. It is just a guideline. So the problem comes in is that if you have too small sample size, your model may not fit very well. If you are, unless and until you have more sample size, then only you should be able to see that your model is valid or not. So you don't want that your sample size may be the reason why you are not able to prove your model. So that is why you have to be a bit more liberal in having more sample size. That is the thing. Okay. Now, so this is a broad guideline. If you want to look at more suggestions, there are certain references which are there in here book, and that you can refer to this. And I just put only some I mean, one or two things, guidelines only I have put. I have not put all the available guidelines are there. Now, another thing with respect to confirmatory factor analysis is typically many of your studies may be a kind of, that is, you may do, you may be trying to validate, or you may try to develop a scale, so for which you may be using exploratory factor analysis. So after completing that particular step, you want to validate it, right? So you may have to carry out, or you may have to have an initial sample for EFA to identify your items. So these items belongs to these particular factors. So that you have to do it. So that initial sample will be useful only for EFA only, or your scale development only. But when it comes to validation, you may have to take another sample. So you may have to go for one sample for EFA for finalizing finalizing the items for each construct. So that will be part of one study. Then you need to have another sample which may be used, whatever data you are going to collect will be used for CFA. So this is, typically it may be possible that many times you may see that people may be collecting multiple samples so that your validation of your model is well established. So it is not that just 100, you may have more than 100 also, because one set, another guidelines are there for EFA. So that guidelines, based on that, you will draw an initial sample, and then a fresh sample you will draw for CFA. Right. Now there is some more issues are there in stage 3. See, when we put this kind of relationship in a model and then we are trying to estimate it, nowhere we are saying that what will be the value of your construct is going to take. So we are just trying to connect the paths only. So once we fit this model, what will be the value of your construct? So there is no, we are not fixing anything in the diagram. So which means that there is no range for the values your constructs can take, so that it has no metric scale. So they can take any value. It is something like when you fit a regression model, the predicted value of y can lie between -infinity to +infinity, because that's how the model is developed, or the model is fixed. So in that case, in this case, so what is going to happen is that we need to make sure that there is some kind of constraint we put, so that we will be able to ensure that what kind of values your constructs can take. So this is in the CFA literature, it is called setting the scale. So basically, the setting the scale means that one factor loading will be set to a particular value. So typically, it will be set. Any value can be set. But typically, most of the software uses that for one factor, the coefficient will be fixed as 1, and the remaining will be adjusted as per this one. So the other one is that you can also set one error variance as equal to 1, and then you can do. So that is also there, but many software will use this. By default, it will use this one factor loading will be, you can see that when I show the output of this, you will see that the coefficient of one of the one variable, the loading of that one variable in a factor will be set to 1. So this has to be done for all constructs or all factors. So many software takes care of this automatically. Sometimes as a modeler, sometimes what people want is that they want to fix a particular variable, its coefficient to be 1, based on some, their own justification, or as per the theory, or based on the variables in whatever may be the reason they want to specify. In that case, it can be specified in the software also that for this particular variable, I want that it should be fixed as 1. I think in R, the first variable in your model will be fixed as 1. I'm not sure whether that is the same trend will be there, but it is typically the first variable will be set as the loading will be, the coefficient will be 1, and all other things will be set accordingly. So this is again, it is required, but most of the time the software will take care of it. But don't think that when you look at the coefficient as 1, don't think that that value is coming as 1. So no, it is set as 1. So that is why its value is 1. So that is the thing. Now, again, when you are going to, so we have specified the model, then you go for estimation. So I'm not going into the technical detail how it is going to be estimated. But once you get this model or estimated, there are few issues which may come. Maybe possible that the model is not fit. So the one problem could be what is called as order condition. Order condition is that your degrees of freedom should be greater than 0 or greater than or equal to 0 at least. So if this condition is not satisfied, your model will not be able to fit. There is some more which is highly technical, what is called as a rank condition. The rank condition comes, what happens is that it is a computational issue when it is not possible to invert a matrix. So if that problem comes, then it is going to be your model will not be fit. So to avoid this order condition, you need to use minimum 3 indicators per construct. Then this order condition will not arise. But with respect to rank condition, it is going to be a bit difficult. So how do you identify this is, if your model is not fitting at all, then it indicates that there is some problem in estimation. So there is some identification issue is there. The other things which you need to look at is that as you know that variances are squared, some are squared items. So you should get a positive value for error variance. If you get a negative error variance, that also indicate that there is some issue is there. Or you have sometimes what happens is that your parameter estimates are very large, very, very big numbers are coming. So see, these big numbers comes, what happens is that when you are trying to invert a very small number, so if I compute 1 divided by 0.0001, and it will be a very big number. So that is why if you get a very large parameter estimate, that also indicate that there is some issue in your model. So the other one is you will get what is called as a standardized loadings. Standardized loadings means that all the values the loadings will lie between -1 to +1. So something like the range of your correlation coefficients. So if you see that your standardized loadings, which are supposed to lie between -1 and +1, or you are estimating the correlation among the constructs, if the values lies between +1, above +1 or below -1, then all these things indicate that there is some problem in the model identification. Now, why these model specification issues crop up is, it may be possible that the relationship direction is wrongly specified, because whatever conceptualized model is there, you need to indicate it to the software that this is the kind of model I need. So it may be possible that you have wrongly specified the relationship, or you have included some variable, but it is not linking that to a particular construct. So you may be assuming that you are having three three items are there for that construct, but when you have specified the model in the software, you have missed one of the item. So that particular item construct is having only two items. Or it may be possible that like cross-loading or lack of unidimensionality, you are linking an indicator to two or more constructs. So that also is more possible. Or it could be possible that when you are writing the relationship, you have assigned the same indicator two times in the same relationship. So now you may be thinking that why it is such a simple thing. I know the path, why I'm going to do. But once your model becomes more and more complex, so it is going to be very difficult to identify these errors. So if for a simple model, it may not be possible to end up with to have these kind of identification issues. But when you are looking at a very complex models, it is possible. It is entirely possible that your model is not estimable, or all these issues are coming. And most of the time, it may be due to these kind of issues. So you have to set it, and then you'll have to go for it. So once you are through up to stage 3, that means you are able to make sure that your model is not having this identification issues, rank condition is not is satisfied, and the order condition is satisfied. You don't have any negative error variances. Your standardized loadings are within the range, that is -1 to +1. Everything is fine. Now the last stage is, how do you assess the model validity? So that is the last stage of your when fitting of a confirmative analysis. As I told you that this is a straightforward one, at least to understand, to come to a decision that your model is valid, because there are series of statistics you will look into, and based on that you are going to make a decision, and they are usually straightforward, not so difficult to do. So basically, almost all these model validity statistics are going to depend upon what is called as goodness of fit, or GOF, and basically it is what is called as a chi-square goodness of fit test, chi-square test. And typically what you require is the chi-square value should be low, and a large p-value indicate fit is good. So basically the null hypothesis here is that your data correlation matrix are equal. Correlation matrix is so you don't have to bother about it. I will ignore that. So if your p-value is more than 0.05, then it is considered to be good. And you can also compute what is called as if you have two comparisons between two different types of model, that also will be compared using the difference in the chi-squares values of two models, and then you can see the significance of that. So that also is possible. But the one issue in this chi-square value or the p-value is that many times if you see that the p-value will be very, very low, the reason is that your chi-square value is going to depend upon the sample size, and as the sample size increases, your chi-square value will also increase. So which means that you cannot simply decide upon if p-value is say less than 0.05, we ignore this model, or we don't. So we conclude that the model is not good, or the fit is not good. So there are certain modifications because of this issue. There are One which is usually followed is these two statistics. One is called goodness of fit index, and another one is called RMSEA, goodness of fit index, and root mean square error approximation. So this goodness of fit index is between 0 to 1. So higher the value, your fit is good. So that is the usual, that is the kind of interpretation about this GFI. So anything more than 0.9, it is expected that, or it is considered that the model which you are fit is considered to be good. So this is the one which you can look at it. The second one is this RMSEA. So here it is exactly opposite of that. Lower is the better. Lower is the better. So typically people go for, some people will use less than 0.5. Then the model is good, or less than 0.8. People will say it is good. Typically less than 0.1 is fine. 0.8 to 0.1 is 0.1 is oh sorry, this should be 0.05 and 0.08, not 0.5 and 0.8. Let me correct it. So anything less than 0.05 or 0.08, then it is assumed that, or it is decided that your fit is good. So people go up to less than 0.1, right? Less than 0.1 is between 0.08 to 0.1. It is considered to be acceptable range. Less than 0.05 is considered to be excellent fit. That's what the usual conclusion is. So these are the 2-1. So even though the chi-square value, the p-value may be very, very low, even sometimes you will see that it is less than 0.0001, but your goodness of fit index or RMSEA may indicate that your model is, your model fit is good. So this is a two statistics people use it. This is what a first level of how good is your model. People look into this. The second one is what is called as incremental fit indices. So this, there are several incremental fit indices are there. So nowadays people use this, many suggest to go for Cfi, what is called as Comparative Fit Index. The one is, the very first one is called NAARM Fit Index. It is between 0 to 1. So 1 indicate it is perfect fit. But the problem with this is that if your model is complex, this NFI will be artificially inflate the value. So that is why it is not that much preferred. The TLI problem is that it avoids this inflation, artificial inflation, but this one is not normed. Normed means that it is not, there is no range for this. There is no range for this. So it could be positive or it could be negative. So higher the values indicate closer fit, but since it is not normed, so we don't know how to interpret this. So the newer one, which everybody, which is preferred, is what is called a Cfi Comparative Fit Index. And again, there are so many other things are there, but usually people use this Cfi. So closer to 1 indicate the better model. It is constraints to be between 0 to 1. So anything very high values indicate that your model is good. Now, this incremental fit indices also can be used for comparing different models. So when you are using it for a single model, then what it indicates is how good is from a null model. Null model means there is no, it is the variances are, the correlation is 1 among, 1, the correlation matrix is identity matrix. Correlation matrix is identity matrix. That means there is no relationship among the variables. So all the covariances or correlation terms between any pair is considered to be 0. So that is what it tests. So so as compared to that model, whether your model is good or not. So if you assume correlation matrix is identity, that means there is no relationship. There is no relationship. So, and then you are including or you are indicating a model wherein you are specifying the correlation. So if this CFI indicates 1, that means then it indicates that your model is better than the null model or the identity model. Correlation matrix is identity matrix. That model better than that. But you can also use it. The values you can compare it with. If you have 2 models, you have fit one model for the same data, another model you have fit for the same data. And then you can use this to compare which model is best. Same way, there are other statistics which are available, like usual, what is called as EIC or BIC. These values also will be useful to compare across models, So one is the model which you fit, whether it is good or not. That is one kind of question. The second kind of question is that if you have 2 competing models, how do you decide upon? So this is how you can use it. You can use these kind of indices to find out whether your model is good or not. Now, the final aspect on this is what is your whether your factor loadings are, if all the factor loadings, the significance of these loadings are nothing but the coefficients in your estimated coefficient. So typically, if it is higher, if it is more than 0.5 or 0.7 in absolute value, not in positive values, it could be negative also. If your variable is negatively related, then you may get a negative value. So if it is more, if usually the standardized loadings will be used. So 0.5 or 0.7, if it is more than that, then we say that our construct or the construct value is valid, or validity of construct is proved. So the other one is there is something called comparative ratio. So this is again another statistics which gives you whether your construct is having high reliability. So anything more than 0.7 in absolute value again is considered to be highly reliable. Right. So when you are so far what I have told you is that how do you conceptualize your model? Then what are the things you need to do, different stages of CFA. Now the last part is how are we going to do this CFA? So what kind of software you require? So for that there are several softwares which are there. One is the most popular one. If you see, most of the time people use what is called as Amos. Amos is a package. It is a part of SPSS, but it is a separate kind of product from SPSS. You have to buy separately. There is one procedure called Calis is there, so that is in SAS. Literal is another software. These are all Amos or Literal, they are all specific for structural equation models, or including CFA. So on the other hand, if you go for R, then there is a package called 11 is there, which has become the standard package for any SCM kind of activity. There is one more package called SCM is also there. So in both these packages, you can fit a CFA or variety of SCM models. There is for other packages like PLS path is there for PLS path models. Stata also has a very good tool to fit this CFA or any SCM model. But only issue comes is that in all these software, how you specify the model is completely different. So because you need to specify the relationship, your model you need to instruct to the software. So many use variety of ways how do you denote this. So if you want to use them, so you need to know the part. I think I not use almost I don't know, one of them has a visual a way you can depict your model. Otherwise, in all these things, you need to mention, you need to write, or you need to mention it that how your variables are related, how your models are there. So that is the one challenge you will face when you are going to fit this CFA. But this, if your model is simple, then it is very, very easy. In particularly, for example, in 11. But once you have a very complex models, then you have to be really careful about how you write this, because based on that only your model is going to be fitted. So you need to, if you want to use any of these software, I will show it with 11 how we can specify the model. But if you want to use any other software, then first is you go and see that how the model components, how the model is written in that particular software. So once you are through, then you will be, and rest of the things, outputs of all these software will be of same type. Hardly any difference will be there. Everything is same. So whatever guidelines I have shown you in my slide, so that you can see, or any help you can in the internet, there are several resources are there. You can see that, and you can easily use this. So before I show you some example, okay, out of these NF5, TLI, CFI, which method is more popular? CFI is more popular. That's what I told you. One question was there. CFI is most popular. And out of this GFI and RMSEA, people use RMSEA. The reason is that you will get even a confidence interval for this. So you can know that instead of a single value, you are also having a range. So maybe your RMSEA is 0.07, but the confidence interval shows that it is between 0.6 and 1.1 or something like that. Then you know that your model may not be fitting good. Right. So I think that was the two questions. If any question is there, then I can take, and then I will show you the example. Any questions, anything?
One or two questions were posted in chat box, sir. They were answered.
I think I have answered it. Anything? Okay. Any assumptions of CFA or factor analysis? So this, as such, I told you that there is not much assumptions are there. So as far as CFA is concerned, there is no assumptions. That's why I told you there is no need of normality, or there is no need of, I mean, you need to have the same kind of variables, say same ordinal variable only, or with all your items should be of same scale. All these things are not required as far as CFA is concerned. So it is up to you whether you want to use a 5-point scale or 10-point scale, or you will use a quantitative variable, anything you can use, right? Okay, so any other questions? Okay, let me move to R. See, you can very well see that when I do it in R, hardly there is going to be only 3 commands for running a CFA or executing the CFA. Or 3 or 4 commands will be there. One will be to fit to specify my model. The second one will be to fit the model. Third one will be to see the various summary statistics. So these are the 3. And the fourth one is basically if you want to plot your model with a path diagram. So that is the fourth one. So these are the fourth one. And again, not much options are there. You only biggest challenge comes is that how do you specify your model? So that is the one you need to learn because of for simple model, it is very easy. But as your model becomes more complicated, then you need to know that how do you specify it. So 11 uses a very logical a text format within which you need to specify your model. So the complete, I'm not showing you the very important symbols only. I'm using it. I'm showing it here. If you want to see the complete model specification in 11, you can see, and with a lot of examples which are there. So it is not very difficult, but only thing is if your model is so many terms are there, then you need to write several steps. So the first one is you need to write what is called as latent variable definition. So, and you need to use this kind of symbol. See, for example, let me use a notepad. See, I wrote that model batting is, in that I have two items, right? X1 and X2. So if I have to write, see, batting is a latent variable. So if I want to write a latent variable, how it is related, I'll have to use something like this. So write equal to tilde X1 plus X2. I'm just giving, there is no need of space or anything. So this is how the model which was there. So if I have to write it, then I'll have to specify the relationship of batting. So because this is a latent variable. This variable is not there in my data file. X1 and X2 will be there in my data file, but batting, it will not be there, right? Same way, if I have bowling, so I use X3 plus X4, and then success equal to X5 and X6, right? So these are the 3 1. Now I am also having a relationship between success and, so this I will remove it. So this is my model. So here I am specifying that these 3 are my latent variables, and these 3 latent constructs are estimated in this form. X1 plus X2, for this X3 plus X4, success is X5 plus X6. All right. So, and then finally my other path which is coming is success equal to batting plus bowling. That is what my relationship is saying, right? Batting and bowling leads to success. So that is what I'm writing here. So this is a usual, not equal to, it should be tilde. Right? So this is the tilde symbol we have to use. So, okay. So this is what you both, most of the time, these 2 only are required. Only thing is if you have a indirect path is there. All these things you need to mention it. All the path you need to mention. Among the constructs, you will be mentioning like this. All right. If there is a relationship between batting and bowling, say suppose from batting it goes to bowling, so that means bowling tilde batting, you will have to write it. So this is what a basic syntax will be there. So all these things you will have to put it in a string like this. So in R, so all these things will become a part of your model. So I'll show you one example. So if you have any variance or say any residual, I was telling you that there is some kind of within or between variance covariance relationship is there, then in that case, you will have to use this kind of symbol, tilde, double tilde. Say E1 and E2 is associated with the first one. So E1 tilde E2, like that. You will have to specify it. So that is what it is. So typically this one in our formula indicate intercept. Usually intercepts are included in the model. Sometimes people remove it from the model. So in that case, you can put -1. So -1 means there will be no intercept. So that is usual way in R how the models are specified. So this is with respect to Lava, but in other software, this syntax will be different. So you need to look for how this syntax is going to be there, And it is also possible sometimes what people will use is that they will use something like this. And that means there is something the coefficient of A is considered, X1 is considered to be A. And then there could be some, say this may be considered as B, something like this. So you are specifying these coefficients A and B, and then there could be some relationship ratio between A to B or something like that. That also will be a part of the model. So these are all different kinds of symbols which will be used. If I want to fix this, say, coefficient of X1 as 1, I can also do like this. That means this coefficient will be fixed as 1, right? So 11 takes care of that setting the scale in the sense that it will ensure one of the coefficient will be coefficient of one of these variable will be equivalent to 1 in the latent variable construct. So that it will take care of automatically, but you will have to do that. So the mistakes which I was telling you is, say for example, I type like this. So because there are so many syntax I will be writing, so sometimes I may, while copying, it should have been say X3, but I may be copying it from X1, and then I will be copying here, and then say I put like this. Then these kind of issues, this will result in the model may not be fitting. Model may not fit. So these kind of errors are very common when you are having you need to write, say for example, there are 5 constructs are there, and for each construct you are having 6 items or 7 items, then it is all possible that this will be very, very messy, right? And it will be very difficult to identify that whether your model is good, is depicted correctly or not. So that is the problem, right? So I will use a inbuilt data set. I did not have time for any other examples. So I'm using a data which is available in this data set is available in the package itself. So basically this is the mental ability scores of the students of 2 different schools, I think grade 8 and 9, something like that. So this course, the Cfa model is something like, there are 3 latent constructs are there, or 3 factors are there. One is called visual factor. So that is measured by 3 variables, x1, x2, and x3. there is a textual factor, which is measured by X4, X5, X6. And there is a speed factor, which is measured by X7, X8, X9. So this is the model, and how they are related is something like this. So here, if you see here, there is all these three are not leading to some math ability you can think of. All right. So all these things are related, are going to this you can also think of. But here the model consider is that visual is related to these three variables, textual is related to three variables, and speed is related to this. And there is a correlation between visual and textual. So that is denoted by this curved arrow. And between textual and speed also, that is again denoted by this curved arrow. And there is between visual and speed also. So these variables are not, they're all related to one another. These constructs are related to one another. So that relationship is also depicted. So it could have been possible that all three will lead to one single construct also, but they are not doing it. So we are having this one only. Now, if you see the code, this correlation is assumed. So anyhow, between the construct correlation, it is going to come. So the model is going to be simple. You see that the visual is related to X1 plus X2 plus X3. Textual is related to X4, X5, X6. And speed is related to this. So you can see that this is in R, this is called a string. So this string, we are depicting that these are the three models we want to fit, or three relationship we want to fit. So no need to add E1, E2, E3, or all that errors and all, we don't have to write it. Only this you need to write it. So these two statements are more than enough to get the answers. So I will run it in R to show you. So this is a function Cfa. If you want to use, you can also use SCM. So that is a structural equation model. The results of Cfa and SCM will not vary so much. All right. So Cfa is the function. This is the model which you have proposed it, and this is your data set, so that you are mentioning, and this result is saved in what is called as fit. So you call this function summary fit, and then if you give fit dot measures equal to true, you will get the all the fit statistics which I have shown you. Let me open my R Studio. Let it open. Yeah. Okay, I'm just showing you, just a minute. Okay, so basically this you need these two files. I think no, these three packages are required. This three package 11 is one package. 11 plot, I think I'm not used. Yeah, you will be requiring this. And there is something called semplot. Semplot will give you a bit more options for improving your plot. So that is why these two are required. Otherwise, if you just want to fit the model CFA, then you require this package called 11. So I am running this as such. The other packages may not be required. And the last package which I am using it is for coloring. This one. If you want to make some improvement in the colors, you can use it. So I'll show you the data set. I'll show you how the data set looks like. So this is your data. So some characteristics of the students are there, and these are the values in that 9 variables, which were used in the model: x1, x2, x3, and so on. And there are 2 schools, and all these things are there. Now, so the very first statement is your model statement. So here we are denoting your model, right? So this is the 3 factors we are defining and how it is related to this. So let me run this. So my model is ready, and then I'm going to call this CFA and then going to ask about this, right? So it is not going to give you any output because it is saved in this. And if you want to see what kind of model we have fitted, if I call this function 11 plot, it shows you that this is the simple model which I have fitted, right? So this is what the model is showing you. And if I want to see the what is the fit measures. So if you just give fit, summary, then it will give you the loading and other things. But if I use this fit.measures equal to true, then it will show you only the fit measurements only. So it will be easier for you to identify whether your model is good or not. So basically, this is what I was telling you about how your model is using simple chi-square test. As I was telling you that, see, there are about 301 observations are there, right? So if I look at this p-value, it should be the chi-square value should be low and the p-value should be high. But in both the cases, chi-square value is very high, and naturally the p-value is very, very low. So if I use only chi-square test, then it is saying that this model is not fitting well. Right, because your null hypothesis that fit is good is rejected. So that means fit is not good. But if you see this, as I was telling you that CFI, right? CFI, so it should be high. So it shows that it is more than 0.9. So here it is coming out to be 0.931. So this is a good fit. It's a good fit. So that means this model is fitting very well to the data set which you are having. The other one which I told you is about this RMSEA. It should be closer to 1. That is what, closer to 0. So anything less than 0.05 or 0.08 is considered to be good. But if you see here that it is somewhere around 0.092, so basically it says that it is slightly on the higher side, maybe up to acceptable limit only. And this is the confidence interval. Ideally, it should be less than 0.01, less than 0.01, but you can see that it exceeds 0.1, 114 it is coming. So this, if you want to test whether RMSEA less than 0.05, this is the standard people use. So it shows that this p-value less than, it is rejected. So naturally, it is more than, it is around 0.09. So it is way ahead of this 0.05, right? And if you see this, these are the estimates. So as I was telling you that one of the estimate for one variable will be fixed as 1. You can see here. So x1, x4, x7 is fixed, and these are the loadings. So typically what you need to look at is that you see that these values are not very unusual, and also these variances are not coming negative. All right, these variances should not come negative. So if it is not there, then fine. The other thing is, I think, yeah, but okay. One more thing is with respect to the significance level. So whether these coefficients are significant, you can see here, all the coefficients are coming out to be significant, right? So all of them are different from 0. But you can ask for standardized loading, because this one you use it for whether your model is good or not. You use this command. If you want to see whether your if you want to look at your coefficients and other things, use these standardized coefficients. So call standardized equal to true. So you will get, so this is the one where if you see the output is same, except this you are having 2 more columns are there. This std.lv means only the standardized, latent variables are standardized. Here, all of them are standardized. So these loadings are, if it is more than 0.05, sorry, not 0.05, 0.5 and above is considered to be good. But here you can see here, I think this one you will have to look at it. So you can see here, everything is coming within less than 1. And all of them are positive. Sometimes you may get negative also, right? And these coefficients are also positive. So that means the relationship between these latents are also positive only. So if one increases, the other will increase. So that is how. So finally, the last one is you can ask for a plot. Simple plot will come using, if you call this function, same paths fit, and then asking for standardized loadings. So it will be, so it shows you the loadings. This is the default one. You can of course change the color and other things. It is I think very difficult for you to look into. So these are the variances, all right? And this is the correlation with itself, and the correlation between them are also shown here. And the loadings, some loadings are coming negative. No. I think this. Okay, I think this is what that it is set as 1. So that is why it is coming in different type of line. So x1 coefficient of x1, x4, x7 it is set as 1, right? So that is why it is shown in separately. It is also possible you can improve upon. I'll just show you one more way. So this is how, I mean, there are several ways you can improve upon. So you need to look at how to change this color or put some kind of text, all these things, right? So you can go on, I mean, you have to change this code or look for this code and you will be able to get it, right? So this, I think I'm done. If you have any questions or anything, you can ask me. So there are a lot of literature which are available on CFA. So you can look into, and as in the beginning itself, I told you that doing the analysis in the software, the very big problem you may face is this, writing this model only. Other than that, many of the things are fairly simple, right? But the only thing is that to come to this kind of relationship, that will be the biggest challenge. You need to look at it. How do you develop these kind of hypothesize relationships? Once you have, and then your measurement variables are correct, and you have able to collect the data, then validation and looking at it will be much simpler. So that is a. So if you have any questions, you can ask me now. I'll be sharing it, sir. I will share this recent PPT because there was the one I shared you before lunch. There was some 1 or 2 mistakes were there, so I just wanted to correct it, and I will send you. And on this code also, I will send. No issue.
Okay, sir. I will collect a revised.
You can share it with everybody. No issue.
You can send revised one, sir.
Yeah, sure.
So that it can be shared to all the participants.
Yeah, sure.
Okay. Any questions, please, participants, the students, esteemed faculty members? Sir, we have with us many of the university heads. Our university head of the statistics department, Dr. V.
Yeah, I know. I have seen him. Yeah, I know him personally.
Yeah, you know personally.
Sir, I know Dr. Dhandapani, sir.
Yeah. You're all friends.
Yeah.
Any questions from the participants? If there are no questions, I request our Associate Professor, Dr. V. Jyoti, to conclude.
So the technique confirmatory factor analysis of immense importance in research, sir. And listening from Dhandapani, sir, is still very great, sir. Sir has given us a very comprehensive picture on this model, sir. Thank you. I immensely thank you, sir. Usually we use this technique in social sciences, maybe for scale construction, or to verify whether whatever relationship we have assumed prior, that is whatever we have hypothesized, whether that relationship between those particular variables is correct. That means we can accept or we can reject, sir. Then sir has even clearly explained about what should be the sample size. So if we have taken 10 items, what should be the sample size? If we have taken 20 items, based on the number of items, at least minimum, maybe 10:1 or at least 15:1. That is a minimum sample size. And the advantage of this technique is whenever we're going for a scale construction or others, we'll be predetermining, that is prior only before the application of confirmatory factor analysis, we'll be determining factors like. So maybe we can assume at least 3 to 4, according to the sir's lecture, at least 3 to 4 factors we have to assume, and under each factor we should ascertain that at least we get at least 4 items and more. And then sir has even clearly explained about the terminologies also. the little doubt, whatever we had also was cleared, sir. So clearly you have explained about the application of chi-square over here and comparative fit index, CFI, and then RMSEA root mean square error of approximation. Also, you have clearly told, sir, what should be the values and all. And thank you very much, sir, even for sharing the softwares through which we can perform this factor analysis, like Amos, Calis, Lisserel, and others also you have clearly mentioned, sir. Thank you very much, sir, for your wonderful and great lecture. On behalf of Department of Agricultural Extension Education, Agricultural College Bapatla, and Acharya NG Ranga Agricultural University, sir, I immensely thank you, sir, for your lecture. Thank you very much, sir. And I even thank all the participants for listening, sir. Actually, we were having 160 participants continuously online, sir. And actually, there were even 100 participants over here. Even the students were also over here, sir. Thank you for your lecture, sir.
One minute, Jyoti. Thank you, Dr. Dhandapani, sir. In between, some disturbances there in net because at Bapatla we don't have power. Okay. That's why I was connected through mobile, and just now I got power, and through LAN I connected again. Okay. Thank you, sir, for nice presentation. And I know about the Amos, but really the R software, which is very simple for running confirmatory factor analysis with 3 steps, which is very nice, and you have narrated nicely about all the criteria, MAPE, MACA, SPC criteria, and how to identify the best fit and all. Thank you, sir, for sparing your valuable time. On behalf of statistics also, I am very much thankful because our students are also there in our participants. Thank you. And at the same time, I thank Dr. Vijayabhanandana, sir, for arranging a nice lecture from our Dhandapani, sir. Thank you.
Thank you, Dr. Srinivas Rao. Hope we will meet tomorrow.
Yes,
tomorrow
sir.
You joining for
Yes, sir. Yes.
workshop? Okay. Right.
Yes, sir.
Thank you, sir.
Thank you, sir.
An announcement for all the participants. Tomorrow we will have a topic discussion on evaluation of extension programs by Dr. PVK Sesidhar, who is the professor of IGNO. Looking after the MSc program and PhD program in agriculture extension education. And tomorrow is the last day. And immediately after the topic presentation, after discussion, we will have valedictory section. I request all the participants to be available for valedictory also and give feedback to organize such workshops in future also. Your participation gives us a lot of motivation to have this type of online workshops or seminars, whatever it may be, for the sake of the faculty, for the benefit of the PG and PhD students. With this, I request all of you to join tomorrow at exactly 1:45 or 1:50 to 2 o'clock. The session will start. At probably we will have 2 hours, and immediately after the session, without any gap, we will have valedictory session. Thank you very much. Thank you all. Thank you. Have a good day. And tomorrow, let us meet again online. Thank you.
Thank you. Right.
We'll conclude it now.